Hi, everyone. I'm just realizing I'm really long-winded here. Normally, a lecture keeps me on pace, but now that I can just talk, I mean, I can waste all of your time. So hopefully, I'm not. I'll hopefully speed things up a little bit, but I want to make sure you have a really solid understanding or comfort with functions. I want to look at multiple source files next because it does actually relate to functions. Now, we only have one main function in our entire project, but we can actually have more than one file, which is kind of weird. In fact, we've already seen this a little bit before. When we dealt with the math library, we included other functions from other people's code. That's what that include was. It included the header file, which had the lines of what all the names of the functions were, and it also linked it up to the actual implementation of those functions so that you can use the absolute value function, for example. Um, we could also put all of our prototypes in what's called a header file. That's just a single file that has pretty much, at least for our purposes, it'll just have all the various prototypes. That means if I have multiple files, everyone can point to that one header file and everyone knows about all the other functions that you've defined, rather than having to worry about the ordering or, oh, but that's not in this file, it's over in this file over there. So here would be an example of using an external file. So here's file 1, file 2 is the other one over here. File 1 has an external variable, global variable, boo, called exvar. This file 2 has exvar as well. Notice it's a global variable, but since it's in this file, it exists in this file. This might be external, but if we see exvar, we're probably referring to this one right here, not this one over here. glvar is not visible at all in file 2. It's only visible in file 1. exvar, this one here though, is visible by file 2 and file 1. All right. My function foo. Here's my function foo. Let's see if I have, does bar actually call foo at all? I want them to call each other, but I don't think they do. So, here's my foo. I can give a prototype for what a function I'm expecting to see. There's going to be a function called bar somewhere. I define bar over here, and as a result, when I go to compile this thing, it goes, okay, there's a function called bar. Where is it defined? Oh, well, I also compile this file too. I'm compiling this file. I'm compiling this file. And so if I have just the prototype and my function is defined somewhere else, I can find that function somewhere else. Oh, by the way, here is me making a local variable with local effects. You can't actually call exvar here and set it to 2. I will actually be modifying this one down here. The variables get created right here. So as a sort of a concept, you want to think of the exvar existing and being created right on this line here, but you can't directly call some external variable, global variable, from the lines above it, but that's neither here nor there. When I call exvar here though, like int exvar equals 9, and then I set exvar to 5, which one am I talking about? I'm talking about the local variable. Local variable first, then global, then external. And that's how you sort of view things. It's always, you start the most local and then you build out from there. We will look at external files some other point in time. It just means that you can have multiple different files, multiple different C files, and when you compile them, as long as they know where everything is, as long as they can hook everything up, you're fine. You can have more than one file in your project. That's why it's called a solution, not just a single C file. You can have more than one file in your project, and as long as they know how to hook up with each other, then you're fine. And this is me having my code distributed across 2 different files, file 1 and file 2. We've actually seen using other people's code in functions before. That's what this math library was, right? This is what our standard output was for printf statements. We've done this in other places. Every time we've called a function that we didn't write, any function that we didn't write, it either had to be a built-in function, but if I needed the include statement, it meant I'm using somebody else's code. And what the include statement actually does is it actually sticks the header file if I have include, math.h, I will put the entire header file, the entire text file, which is math.h, and stuff it right there wherever my include statement was. Much like I have just a single line saying there's a function called bar. Later on, it'll figure out how to hook everything up. So that's what the include statement has been doing. But you need to be able to link all these things up. And so what we normally have is we have these prototypes that allow us to find where everything is. We build our objects, and then at the end we do a linking, which is to hook up, to point out where all the functions are. So if I have a prototype called foo defined one place, but the prototype somewhere else, when I call the function, it goes to the prototype, and then it goes to the actual definition itself. So standard library, the standard library, or math.h are both include header files. And when I do this, the big thing to point out, why sometimes I have quotes, sometimes I have angled parentheses. Half the programmers I know don't know what the difference was. In fact, I don't think I knew the difference until a couple of years ago. This here, math.h, it is the standard path. It's where you put all your most important header files, most of your libraries, the main libraries you have. But not in your project. It is for all of your C code. So imagine where your documents, all your documents are stored in documents. They're not stored in this particular folder. They're just stored in documents. Right? All of your library stuff is stored in one particular folder, and Visual Studio knows where the heck that is. My file.h, however, looks in the same directory as you're in right now. So technically, you could have dot, I think it says slash this way, which goes, go up one level in my directory structure, and now look for a file called MultipleFiles.h. You probably shouldn't do this, but you could. This is the kind of thing, it's just saying, look where I currently am, look for a file named myfile.h. Here is, go to the main directory where we store all of our libraries, look for a file called math.h and include it. So here are some of the standard libraries, standard IO, string.h, which we're not going to be using, time.h, which we are going to be using. It gives you dates and times. Math.h gives you standard math functions. Signals, standard arguments. In fact, I don't know half of these things simply because I use them when I need them. I have probably used all of these different libraries, but I don't remember what's in them. When I need a particular function, I will look up what library I need to include. I include that library. And Google's your friend in this case. And again, I think we briefly went over this already, but the math library, these are the kinds of functions you can have from your math library. So if I include the math library, I can now call square root of x, and I can get the square root of a value x, right? Or ceiling, or the tan. When I'm building, I think we went over in the overview, but just to remind you, when I'm compiling my code, what am I doing? I take a text file, which is our source file.c, and I will compile it. So I have pre-compiled header instructions. So there's actually a preprocessor instructions. There's actually one other step above this. That's this standard IO thing. Do some extra stuff in there, right? Do the includes, for example. Then I compile my code, take it from a text file, and make it into an object file. I also know where the standard library is. It's included somewhere else. And I know that standard.io.h, that links up to the standard library. And so when I have two object files, then I link it up so that my object file now knows where my code is, where printf is. Object file now knows where printf is, and can call that particular function. And what I get in the end, I get an executable file. This is a binary file. It is just zeros and ones that the computer can actually use. It can just run and execute it. But it's actually a three-part process in order to get there. The first part being pre-compilation, then compilation, and then we link everything up. So I don't know if I want to go over the different versions of the math library. Just a quick reminder, though, in case you are confused by it. We have seen this function before. In fact, we actually have at least 3 different main functions available to us. You can only have one at a time, but the 3 different implementations of main that you can do. There's version number 1, which is void main. That is, it doesn't return anything at the end. Is this line necessary? It is absolutely not. Not necessary in the least. So I can leave this line off and everything works just fine. The main method or the main function does nothing. It doesn't return any values. I can have a different implementation of main which has an integer, and then I should or need to return some kind of integer. This allows me to return values. If I get an error, there's something wrong with my program, I can return some value and that could be used somewhere else. It doesn't come up in this class, but that's the reason why main could have an integer. And then there's a third way, which is a standard IO, which is a way that will take in an array or vector of different inputs. So when you run your program from the command line, you can put in extra arguments, other things after calling calling your program. And if I actually I can pass those other parameters or those other values as text into my program. We'll see that in the lab. All right. So if you want more practice, here are a couple things you can do. So try and write a function that calculates the distance between 2 points. Now, I don't know if you remember how to do this. You can either do the metropolitan. Is it metropolitan or New York distance? Anyways, maybe let's call it metropolitan distance, or city distance. A block-shaped distance, so you can figure out what the difference between x1 and x2 is. What's that value? Figure out the difference between y1 and y2. What's that absolute value difference? That would be the total distance you have to go. Or you can do as the crow flies. So option 1 is here, or option 2 is this. That requires it's the hypotenuse, right? So you do Pythagorean theorem. So calculate the distance between 2 points. Great exercise to get more practice on how to write a function, right? You'll know how to write a function a whole lot better if you can do that. Or maybe figure out if a point is within a rectangle. So a rectangle can be defined as an x and a y, a width and a height, and a point is an x and a y position, and you can figure out if that the point is actually within the bounding box of the rectangle. Or maybe you could figure out if a point is in a circle, where you have the center point of the circle and the radius of the circle. All would be great examples of how you write a function, and good practice for you to make sure you're comfortable writing functions. All right. With that, we're going to be moving on to bigger and bolder things next. We're finally done functions. We're going to be looking. What are we looking at next? I'm curious to find out. Actually, I do believe it's conditionals is next. So it's going to be like if statements, whether your program does this in one case or this in another case. And we can look at how you can change the behavior of your program using conditionals. All right. Thanks, everyone, and I'll talk to you soon.